hello everyone. Welcome to another video in my Apollo Moon Hoax series. Very happy to have Marcus Allen back for another interview. As you know, Marcus is the UK distributor for NEXUS Magazine, Marcus Allen. And I just got my new copy today. How coincidental. I'm interviewing the same day my new copy arrived. Fascinating articles in there. And of course, and I've mentioned this before, that Marcus Allen is the co-writer with Trevor Weaver of the book, The Apollo Moon Hoax, The Real Evidence. And so today I thought we will do something a little bit different. I discussed this with Marcus before we recorded, and Marcus graciously agreed. I'd like to do actually a video series on Marcus Allen's book here. I've read the book. I'm actually going through it a second time because I'm making a lot of notes. How are you, Marcus?
I'm very well, thank you, Randy. Great to be chatting to you again.
It's been too long, things get in the way, and I'm so happy that we connected again, and I'm really looking forward to this video series on your book. It's actually a very good book. It has a lot of information in it. For those of you out there that haven't read it yet, there's a lot of information, a little bit of math, but Marcus and Trevor do the equations for you. There's not much math in there. For those of you that are not mathematically inclined, you can definitely read around it. They make the point with or without the math. And that's only in I think one chapter, a couple of chapters, is not much at all, but very informative book and carries with a lot of information. So you can't do this book justice in just one video. So anyway, Marcus, I thought maybe we would get started. What I'll do is we'll start with chapter 1.
Start with chapter
1. And
one.
I'll give you the page number, 23, the very first paragraph. So that's chapter 2. So what I'll do is I'll read out the paragraph for the people watching the video, and then we can discuss it from there. So I'll read the first paragraph here that I have marked out. One of my favorite assertions universally offered by the pro-NASA brigade is that in 1969, it would have been easier to go to the moon than to fake it. This idea has no evidential basis. Rather, it is based on an incomplete understanding of how NASA X did fake it. It is a fact that back in the 1960s, there were no advanced computer graphics possibilities. Everything needed to be captured in camera. However, post-production possibilities were available to a limited extent using an optical printer, which enabled NASA X to create the fake videos. So it has been an old argument for years that I keep hearing this. And even when I didn't delve into the Apollo moon missions, before I delved into them on the amount of research that I had done, even then I didn't buy that argument. I mean, it was just a silly thing to say. It would be easier to go there than it is to fake it. And my assumption was proven correct when I did the research. But Marcus, please elaborate on that, because I really do want to hear what more you have to say about it.
I think before I do, I just think there's a couple of definitions we should clear up. If anybody's not familiar with them, they probably think, what are you talking about NASA X? What's that all about? Right, NASA X in this book is the original clandestine group within NASA, the people who were going about the faking. Now, the first chapter of the book covers how do you keep a secret of 400,000 people? Well, it's actually one of the most ridiculous questions you can ask. 400,000 people didn't need to keep a secret. They didn't know anything about it. They saw Apollo the same way we all did, on television. We'll come to television in a minute. So NASA X are the group within NASA who have been responsible for creating the images and the story of the hoax. This is not NASA themselves, National Aeronautics and Space Administration. This is an internal, quite small group, probably amounting to no more than about 40 or 50 people. And the other definition I think we should cover is what is an optical printer. Now, everybody's familiar with a photocopier, which is a paper printer. It copies original onto paper. An optical printer, as the name suggests, is what copies film. If you start with a film and you want to copy it, or create or change it in any way, the speed of it, the number of frames, you use an optical printer. It's basically a camera projecting a film which is being re-recorded by 1, 2 or more other cameras. That's an optical printer. It's been around for a long time. It's quite well understood technology, but if anybody's unfamiliar with it, just look it up. Any decent website will tell you what an optical printer is. So I thought we should maybe just clarify that so that we know what we're talking about. So not easier to fake it, we say. Of course it was easier to fake it. They didn't have to go anywhere to do it. You know, maybe to Arizona, maybe to Mexico, maybe other locations which were filmed and used in the fake. But going to the moon, well, they still haven't done it yet, because that's my contention, that no human, note the word human, us delicate little creatures have ever flown to, landed on, walked across, photographed, picked up bits of rock and returned to Earth. No human has done that. Machines have done it, yes. I don't doubt that for a minute, but not humans, us delicate little creatures. We'll come to why they were delicate little creatures in a minute. But that is the reason it's so easy to fake it and so hard to make it. And of course, you get the normal comments from people who appear to know what they're discussing. Dallas Campbell, who's a BBC technology, and Click is a BBC television program about technology, presenter. The technology to fake the moon landings, he said, this is Dallas Campbell, technology to fake the moon landings did not exist in 1969. The technology did exist to get to the moon in 1969. Now, I agree with that. Unmanned craft had been to the moon for 10 years at this point, but not humans. That's different. I don't know how he knows that the technology to fake it wasn't available. He obviously doesn't study much film technology, because there were people who were doing this sort of stuff in 1969. Remember that famous film, 2001: A Space Odyssey, directed by Stanley Kubrick? That was a remarkable film. It was made in 1967, 1968. Stanley Kubrick was working on it in 1969. He was promoting it. And Stanley Kubrick always worked in the UK. He didn't like flying, so he didn't go anywhere. He had his own manor house near to his film studios, north of London. 2001: A Space Odyssey was filmed in London, including the Dawn of Man opening sequence with the apes. They were men in ape suits, very well trained, very good, very persuasive, and probably the most famous jump cut in film history. The ape throws the bone into the air and it comes down as a spaceship. Incredible. It wasn't Stanley Kubrick who was directing this faking. But if there's a connection with Stanley Kubrick, I claim or suggest that the person who assisted NASA, because he'd already worked for NASA, in creating the effects was Stanley Kubrick's special effects director, Douglas Trumbull, who's recently passed on. He was acknowledged as being probably one of the very best special effects creators in Hollywood, which is where he worked. And he worked with models. He worked with periscope cameras, a sort of camera you use on a model, which when the film is then projected, it looks life-size. He did everything in camera. There were no CGI back in 1969. It was all done using film cameras. That's the key point. So not easy to fake it. I think it was much easier to fake it. Going to the moon, that's hard.
Couple of follow-up questions, if you don't mind. Marcus, when we're talking about the technology in terms of the photographs and the film back in the 1960s, I'm beginning to find out some things too, and I wonder if you will agree with me on this. You know, it's very interesting that you mentioned 2001: A Space Odyssey. I'm beginning to believe that if you go back to 1962, Stanley Kubrick's movie, Dr. Strangelove, and in that scene, some really good scenes, even by today's standards, involving the B-52. So before that movie was made, Stanley Kubrick had asked permission from the US Air Force to photograph and inspect and photograph a B-52 for his film, and he was turned down. So he got basically all these manuals, everything that was available to the public on the B-52. And he came close, like almost 98% close to designing an actual flight deck of the B-52. And it so impressed the US military that they then decided that they needed to connect with this man. So my question to you is, even though we know on the surface that they didn't have the photo and film technology back in the 60s, obviously, as they had today, would it be a pretty good assumption, or maybe we can speculate a little bit, that the military might have had far more advanced photographic and film expertise and methods that are actually still classified to this day?
I don't doubt that for a minute. The American military are forever claiming they have secret technology in black budgets, uncosted black budgets. Now, whether they do or not really doesn't matter, but they claim they have. But if they have technology which they were using or they had access to 50 years ago, it's around the time of Apollo, coincidental or not, if they had technology available then, are they using it now? Is that what we call the stealth technology, where aircraft can be made virtually invisible to radar? It could be, because there's so much we don't know. It's important to emphasize that film, photographic film, was what was used to create a great deal of the Apollo record. Now, photographic film, not digital. Digital cameras came in 1975, after Apollo. So don't go confusing the two, please. Digital cameras work quite differently to photographic film cameras. They can be protected much more easily. They're not subjected to a lot of the severe problems that we meet in space, such as the vacuum. The original question, was it easier to go to the moon than to fake it? Well, obviously people who say it, and there's more than Dallas Campbell, there's S.G. Collins, who works at post-war media. He's the guy who posted a film saying, well, of course it was all real, you couldn't fake it. This is S.G. Collins. Some people say that in 1969, people were incapable of sending a man to the moon, but they were capable of staging the whole thing in a TV studio. In fact, the opposite is true. It's the same thing as Dallas Campbell. By the late 1960s, they did have the technical ability, not to mention the requisite madness, to send 3 guys to the moon and back. They did not have the technology to fake it on video. How does he know? It wasn't faked on video, guys. It was faked on film. The technology on video was relatively primitive back in 1969. The technology of film was quite advanced. It had been in use for 70, 80 years at that point, from Molière in France, Charlie Chaplin in America, through to Kubrick with Tunes of Glory, his first major film, Spartacus, with Kirk Douglas. So film technology was very well understood. And all the special effects that we see in the old, well, now from 2024, the old films back 60, 70 years ago, all those effects were done in camera, using models, using special effects that would appear on film. So of course it was possible to fake it. It's just, he obviously hasn't done enough research. Then we have livescience.com, Howard Berry. I can say with certainty that the footage would have been impossible to fake. How does he know? No evidence provided. That's an assertion. Anybody can assert things. Dr. David Wright, the astronomer at Griffith Observatory. I think going to the moon was easier to do in 1969 than it would have been to hoax it. What does he know? He's an astronomer. He's not a rocket scientist. Anyway, there's all sorts of people, and we try to put quotes in the book, those are just 4, of people who are apparently knowledgeable about space. I mean, astronomers presumably study space, that's what it's there for. But they make these ridiculous statements, which don't back up. They just make a statement as if we should just accept it because he said it, and that it must be true because he said it. No, that's not the case. I say no human has landed on the lunar surface. Is it because I say it, you should believe it? No, you should investigate it, as I have done for 30 years. So let's get over this idea that it's easier to go there than to fake it. It's not.
And I think, too, that I always listen when somebody's saying that, it doesn't matter who they are, a physicist, any type of scientist, when they're saying that, I always listen to what they say carefully. Like they usually, and some very choice words. For example, I think it's easier to go to the moon than it is to fake it. Or, yes, we have the technology to go to the moon, but they don't clarify whether they mean manned missions or unmanned missions. That's a nuance that I'm getting into here. But the point being is that I often think that they cover their bases. Like when I'm talking about my own work, I will say sometimes I'm speculating. I don't have a smoking gun per se, but what I am doing is I'm presenting what I believe is evidence or circumstantial evidence to put forward for the reader to say, yeah, hey, something's not right here. I'm going to look into this for myself. That's kind of where I'm at. But my own conclusion is that they fake the missions. But the reader out there has to come to that conclusion themselves. And they have to, which means you got to walk through a lot of research. It's just not something you're going to be able to decide overnight. So you got another thing here, question that I did bring up across my mind here. You mentioned delicate creatures. Could you follow up on that?
Okay. It's basically the problems that humans not unmanned craft, humans face traveling in space. We have to make sure the difference between an unmanned craft, i.e. a robot, and a craft carrying humans, us delicate little creatures, there is a vast difference between them.
Yeah.
Unmanned craft can be protected against the problems in space. The major problems in space are three. The heat generated by the sun. Oh, I hear you say, there's nothing in space. No, that's quite true. There's nothing in space until you put an object in space, which will then have a temperature. Earth has a temperature. It's about 15 degrees centigrade, the average temperature on Earth. The moon will have a temperature. It varies considerably. Jupiter, Mars, Uranus, Saturn, all the other planets, they all have temperatures, but space does not. So when you put a spacecraft with humans inside in space, it will have a temperature. It can't help it. That's the way it works. That's physics. There's no dispute about it. The spacecraft will have a temperature. So what is that temperature? And the answer, using the black body radiation calculation, which involves the Stefan Boltzmann constant, will give you the answer. 246 degrees Fahrenheit, or about 120 degrees centigrade, i.e. hot enough to cook your chicken at. So how do they keep cool? You cannot air condition anything in space. There's nowhere to dump the heat. Yeah. Space is the best insulator around. A vacuum is a brilliant insulator. That's why we have thermos flasks. They're vacuum sealed containers. So if you've got a vacuum in space, you can't dump the heat from inside the spacecraft. It has to be radiated away. That's the only way you can reduce heat in space. That's what happens on Earth. The heat is radiated back into space. But the constant temperature that we maintain here on Earth can be calculated quite easily. And it has been. Same way that an internal temperature of a spacecraft containing humans can be calculated. And 245 degrees Fahrenheit is too hot for humans. So the only way they could remove the heat from inside the spacecraft is to radiate it away from the spacecraft by using water, which they had to carry with them, which when put out into space outside, away from the sunlight, will freeze, and it will then remove heat. Now, the International Space Station, I hear you say, orbits the Earth, about 200 miles up. It spends half its time in the Earth's shadow, very cold. The other half of the time in the sun, very hot. So how do we know there's a problem, even with the International Space Station? When the first space shuttles were launched in 1981, Columbia was the first one launched. Astronauts carried in the space shuttle were going up to repair satellites and generally work outside, build the International Space Station, all the other things they were doing. And every time they went out in the first cruise, they complained that their hands got so cold they couldn't use them when they went into the Earth's shadow. They spend half the orbit in the Earth's shadow. They go into the Earth's shadow, hands get cold, can't work, so the astronauts complain. Can we have electrically heated gloves, please, NASA? NASA says, don't be so stupid. Of course you can't. It's not that cold up there. Here's a thermometer to give us some readings. So next shuttle went up, had a thermometer, took the readings. Long story short, when they go from sunlight into darkness and shadow, the temperature drops by well over 100 degrees centigrade within a few minutes. Similar, come out of shadow into sunlight, temperature rises by over 100 degrees centigrade in a few minutes. They got their gloves heated. Heat in space generated by the sun is a major problem. And when you put the lunar lander allegedly on the lunar surface in bright sunlight for 3 days, that's 72 hours, in the case of Apollo 17, how on earth did they keep cool? Could they carry enough water to remove that amount of energy from within inside the spacecraft? I don't think so. So you've got this problem of heat. I mean, that's just one aspect. The other aspect is something else the sun produces. It's called radiation. And the sun also produces solar particle events, SPEs, solar flares. We've had one here quite recently. We could see the aurora borealis way down. I could see it in London. I mean, you shouldn't be able to see the northern lights, they're also called. I mean, you saw it in Canada, didn't you?
I personally didn't see it, but I had heard reports. And for you to see it that far down in terms of latitude indicates how powerful that storm is. You gave a very good description in terms of the astronauts, when they're going from transiting from the light side of the Earth the heated side of the Earth to the dark side and where it gets cooler. I've heard proponents of these missions say that, because of the vacuum of space, it takes a lot longer for an object to heat up. And they come out with all kinds of comebacks like, well, on the moon, they were landing near the Terminator and it wasn't so hot then, and so on and so forth. But you just described within a few minutes, their hands were getting cold as soon as they entered the dark side of the Earth. And it really does indicate that of all of the elements are major, but that was one of the major problems that they would have had in sending manned missions to the moon and back. That's why they came out with reflective material to try to dissipate the heat, or to reflect the heat rather. As you mentioned, they could only dissipate the heat through radiation and radiative methods. Then there's also the passive thermal control. So that was a big problem, except for the Apollo 13. We'll get into that one later because that's a really good one, right? Yeah. But I want to wrap up this particular paragraph here. The first paragraph after the quotes that you have here, the first paragraph, what the Apollo protagonists. So what the Apollo protagonists do not appear to realize is the efforts NASA made to train the astronauts using realistic simulators. This was essential to accustom the astronauts to the machines that they would need to control on their mission to the moon. These same simulators that gave the astronauts realistic views of the approach, orbit, and landing on the moon could also be used to fool the rest of us, which is exactly what happened. And I just want to read the next paragraph, and then I'll let you elaborate on that. It was not only the astronauts that required extensive training, but also the mission controllers. To do this, NASA created many simulation exercises that covered the complete mission. On 13 December 1967, NASA launched the Tetra-A satellite. The purpose of this satellite was to simulate transmissions coming from space and the moon so that the controllers of mission control in Houston could rehearse the complete Apollo missions. These simulated transmissions would also appear to be a perfect source for the fake transmissions later to be used on the real Apollo missions. These were not only intended for the training of mission controllers, but also to check out all the communications and ancillary equipment. Now, there's 2 points there with the first 2 paragraphs. The first one being that they were using simulators for the astronauts, and obviously they were filming that at the same time, and that could have been very much used in actual film that we see of the supposed missions. The second point is the next paragraph, that they were using satellites to train, bouncing communications off those satellites to and back in the moon to train mission controllers.
And the comment by Gene Kranz, who was flight director on every odd-numbered Apollo mission, was that they couldn't tell the difference between a real and a simulated transmission. Where the signal comes from is not something that you see on your screen. So the idea that this could not have been fake, as you said, they had the simulators. They had the command module simulator, they had the lunar lander simulator, and they also had, in 1966, 1967, they had sent an unmanned satellite called Lunar Orbiter, not to be confused with the Lunar Reconnaissance Orbiter, that comes much later. The Lunar Orbiter was sent to photograph possible Apollo landing sites. Now, when you're simulating anything, like if you're in a flight simulator for an aircraft, you want to see what's outside you because it gives you a clue as to how you should control the aircraft. Same with an astronaut. They would need to see what's outside them as they're approaching the lunar surface, getting close to it or getting further away from it, depending on where they were supposed to be. So there would be film projected outside the simulator's windows showing this scenario, the approach to the lunar surface. It had been filmed previously by the Lunar Orbiter for that purpose, probably. So anybody who says, well, look, you can match up the real, inverted commas, the real photographs and films of, say, Apollo 11 landing with what other people like the Chinese, the Indians, the Japanese claim to have photographed as well. Yes, of course they did. Of course it's the same thing. It was filmed by NASA in 1966. That's all they're using. Everybody will use the same images because who else has been to photograph the lunar surface? Oh, the Chinese, the Indians, the Japanese. That's a whole other story. We'll maybe come to that this time at some point. But the idea of faking it becomes very plausible. And there's a phrase that a friend of mine who knows of my interest in these subjects used to describe it. He says it's the emergent algorithm. Now, we've talked about Apollo hoaxing for many years. I've been researching it 30 years. I've gathered information. gathered snippets here, snippets there. I've listened to people talk. I've watched films. I've read books. I've looked at magazines. That's called research, in case anybody wonders. Oh, it is to me. 30 years of it, it starts to mount up. And there's a tipping point where instead of possibly they did land, but there's all this sort of but ifs. It could have been faked. Maybe not all of it was faked. There's all that going on. There's a tipping point where you say, no, it was faked. I know. This is why. And that came to me about 5 or 6 years ago, that tipping point, when I discovered the problems with vacuum in space. That's something which we can get onto here. But vacuum in space, for me, was a tipping point. It confirmed what I believed to be correct.
Please elaborate.
All right. Basically, space is empty. There's nothing there. That's called a vacuum. It's got no heat. It's got no temperature till you put an object there. But as soon as you put an object there, manufactured here on Earth, like humans, like spacecraft, the vacuum will have an effect on that object or person. If a person goes into a hard vacuum, that's about 1,000 miles up, he'll die if he's not protected. You get to the moon, it's a very hard vacuum. Now, vacuum is measured in units called torr, T-O-R-R, named after an Italian scientist who developed an early barometer, Evangelista Torelli, his name was. So torr is the unit of measuring vacuum. Here on Earth, we don't have a vacuum. We have an atmosphere. We have a pressure here on Earth of 14.7 pounds per square inch. We don't notice it. It's about a ton per square yard. It's quite a lot. There's a lot of atmosphere up there pressing down on us. But we're designed in such a way that the pressure inside our bodies counteracts that. We have no effect. You go along in a car at 60 miles an hour, stick your hand out the window, you'll see how much atmosphere there is. You'd have a hard job keeping your hand in place. Go up 5 miles to the top of Mount Everest, and there's much less atmosphere. Climbing up, I think the figure is 26,000 feet. Everest is 29,000 feet. Above 26,000 feet, it's called the death zone, and that term describes it precisely. That is where humans can die quite easily because their bodies are not acclimatized to that level of lowered pressure. It's not as if there isn't enough oxygen at that level. There is. It's just that the pressure of the air is insufficient to force the oxygen into your lungs against the back pressure within your body, holding that oxygen out. That's why people suffer from altitude sickness. There's all sorts of things. But these astronauts, the named astronauts, the 24 astronauts who allegedly flew to the moon, launched their rocket from sea level. Florida's quite low. Within 2 minutes, they're out of sight, about 50 miles up. 50 miles up, that's higher than aircraft fly. How much acclimatization did they do? Very little.
I have been reading some material on that from NASA, and they're very concerned about the vacuum of space. And they do mention exactly what you're talking about. The higher you go, the more powerful the vacuum is. And it is a problem. It's a problem not only for film, which you and Robert and Scott have done some very good work on, demonstrating the effects of the vacuum of space on film, which they would have been using back in the 1960s. But it also has an effect, if they're not careful, has an effect on spacecraft surfaces as well. So it is something they're constantly concerned about. Now they come up with, technology and metals, and, they design metals that to try to mitigate that, but it's still a problem, right? It's still a problem. And when I think about it, and this just popped into my mind before we get to Apollo 13, because I do want to get into that. It's a good one. I was thinking of, when you mentioned that, I was thinking of the lunar module, and the walls of the lunar module, even by NASA's own description, specifically the walls around where the crew compartment was, had the thickness of 3 inches of kitchen foil. I wonder how outgassing in the vacuum of space had affected that.
Exactly. There's 3 layers of kitchen foil, not 3 inches. 3 inches.
Yeah. Oh, sorry. 3 layers. I didn't mean 3 inches. You're right, Marcus. 3 layers of kitchen foil. Yeah. So that's nowhere near it's not even near an eighth of an inch. So when you think about that, if it was realistic, if these missions really happened, we never hear anything about that in terms of the outgassing and the effect of outgassing in the vacuum of space, especially on the lunar surface, the effect it would be having on the crew compartment of the lunar module. You never hear about that.
Good point. Just to clarify, the term you mentioned, outgassing, that is what happens in a vacuum. Now, most people are familiar with that school science experiment where you get a bell jar, and you put a bowl of water inside it and you pump out the air. That's not a particularly hard vacuum. It just demonstrates that when you pump the air out, the water boils. It's called outgassing. That is what outgassing is. Basically, the lighter elements within any material, whether it's water or your lunch or your dinner or whatever, that will outgas. And the lighter elements, like the hydrogen, the helium, the oxygen, all the lighter elements come out first. Aluminium and metals outgas as well. In a hard vacuum, aluminium outgasses. That is why the result of that outgassing of metals is something called cold welding. Welding is where you melt two metals and stick them together. Cold welding is where you don't even need heat to do it. You need a vacuum. And that is actually quite a well-known technique. It is used, vacuum welding. So you've got this dichotomy between the apparent invulnerability of the Apollo spacecraft and the science. This has nothing to do with conspiracies. Forget conspiracies. This is science. You can go into a lab and check it. Check it. Check it. Check it.